And we're going to practice question set number 3 here. This is on concept 14, which is force versus time graphs. Whenever we see a force versus time graph, whenever we see them, whether it's yesterday or today or 3 months from now, we should always think 3 words. And what are those 3 words? Richard? What are the 3 words that we should think of here?
Force, time, and something else?
Nope.
All right.
Colton?
Area equals impulse.
Area equals impulse. Area equals impulse. Every single time, area equals impulse. We know that we're going to end up finding the area of this graph. Even if we're not looking for the impulse, we're going to find the area of this graph. Now, before we move on, we should do this with any graph that we see, including this one. We see force in the y-axis in 10 to the 2 newtons, and time is in seconds on the x-axis. That's important because we're going to do a calculation. If we need to do a calculation for this, we need to include that 10 to the 2 in our calculation. Question 1, we've already answered that, right? The area under the curve represents the impulse. If we remember those 3 words, we nail this question easy, right? Now the next question we should get as well, if we read carefully, the impulse experienced by the car from 2 to 5 seconds. This is area, right? Except it's the area between 2 and 5, not the total area. So we're just looking for, between 2 and 5 seconds, we're looking for this section and this section between 2 and 5 seconds. Area 2 is base times height because it's a rectangle. The base is 2. The height is 20 times 10 to the 2. Right? We got to put in the 10 to the 2 there. We calculate that, it works out to be 4,000 Newton seconds. And then area 3 is 1/2 of base times height. The base is 1 from 4 to 5, and the height is, once again, 20 times 10 to the 2. That gives us an area of 1,000. We add those up, and the total area, which is the impulse here, is equal to 5,000 Newton seconds. So the answer for this one would be B. 5.00 times 10 to the 3 kilograms meters per second. I think they really erred with the way they wrote this question. They gave us a nice 10 to the 2 power or exponent with the units on the y-axis. One of these options should have been 5.0 times 10 to the 1, right? In other words, you forget to use the 10 to the 2, that option should have been there. Normally it will be. Normally it will be. So just be aware of that. In this case, if you hadn't forgot the 10 to the 2, you would have gotten away with it because you would have saw that the option wasn't there. But normally it will be. The answer is B. Next one. A third and final one says a group of students performs an experiment to explore a non-uniform accelerated motion in which the magnitude of the force applied to a low-friction lab cart increases as a function of time. The mass of the cart is 0.50 kilograms. Here's the graph. Force is a function of time. Right away, we're going to think the same thing as we always do. Area is equal to impulse. And then we're going to check our axes. 10 to the minus 1 newtons on the y-axis and 10 to the minus 1 newtons on the x-axis. All right. Not a huge deal. We just have to catch that. Based on the graph above, if the low-friction cart starts from rest, in other words, VI is equal to 0, and the final speed of the laboratory cart is what? Well, I don't know. Let's find the impulse. Find the area, which is the impulse. Let's do that first. This is a triangle, so we'll say 1/2 base times height. The base here goes from, what is this? 0.2, 0.4, 0.5? Yes, not from 0, but from 0.5 to 8. So the base would be 7.5 times 10 to the minus 1. You got that? How many people said it was 8? Easy to do, right? Easy mistake to make. Just watch that. The height goes from 0 to 3.1, 3.2, 3.3, 3.4. So the height we're going to say is 3.4 times 10 to the minus 1, which gives us an area or an impulse of 0.1275. Is that my answer? Bubble that in? Now that's my impulse, which I need because I'm going to set my impulse equal to m times delta v, right? Not f times t, never f times t, rather m times delta v. We're going to say delta v is equal to delta p over m, and delta p here is 0.1275 over the mass, which is 0.50. Do the math there. It works out to be 2.56. No, 2.55, I think. Is it 2.55 or 2.56? 2.55, yeah. Times 10 to the minus 1. But we actually have to round it. Look at this. It says A decimal B times 10 to the negative C. A decimal B times 10 to the negative C. This is A, this is B, and this is C. So we're rounding this to 2 digits, right? The third digit is a 5, which means the second digit rounds up. So this is going to be 2.6 times 10 to the negative 1, which if we record A, B, and C, we're going to say it's 2, 6, and 1. So my answer for this is 261. How many people actually said 261? How many people recorded it properly? Okay, we'll get the hang of recording it. If you were to write a quiz on this, we'll probably do this quiz not tomorrow, but probably the next day. Yeah, I think we will do it on Thursday. If you were to record something like this incorrectly, I'd still mark it correct for now, just because we're just kind of starting to get the hang of how to record these. As long as you have the right answer, we'd probably record it correct. Good.